We're going to talk about gas density. Let me begin by reminding you what we mean by density. So density equals mass over volume. Always write it like this to remind you that it makes a heart. So density equals mass in grams over volume in a unit of volume, which could be milliliters, it could be liters, it could be cubic centimeters. All of those are used. It's milliliters there. Let's make sure you can read that. Okay. Now, to derive a formula for gas density, we're going to begin with the ideal gas law. And let me remind you what each of these symbols stands for. So P for pressure, V for volume, N for number of moles, R is the ideal gas constant. So let's write down what that is. We're going to be using liters and atmospheres. So it will be 0.08206. Liter, atmospheres, per mole, Kelvin. So that's the ideal gas constant we're going to use. And then finally, T is for temperature, and temperature must be in Kelvin. Now I'm going to rearrange this equation into a form which would give us molar density. You say, what is molar density? Well, we typically mean when we say density, grams per volume, but we can also express a molar density as moles per volume. So this is another way of thinking about how far apart or how close together things are. When we talk about density that we typically mean, we're talking about how close together or how far apart matter is. Are the particles packed close together? Are they spread out? In the case of molar density, it's really the same thing in the sense that we're talking about how close together or how spread out moles are. And by this we mean individual particles. So molar density doesn't consider how heavy the particles are. We can actually find molar density from the ideal gas law by just putting moles over volume. So let's do that. So moles over volume is going to equal, so we moved volume over here into the denominator, pressure over RT. So just by rearranging this equation, we get molar volume. Can we change this molar density? I said molar volume, but it's moles per volume, so molar density. Can we change this molar density into density in terms of grams over volume? And the answer is yes, it's very easy. All we have to do is multiply both sides of this equation by molar mass. Molar mass. So what are the units of molar mass? Grams per mole. So look what happens. The moles cancel and we get mass in grams over volume in liters. So let me rearrange and write this again. So molar mass times pressure over RT is going to equal the density of a gas. Now, this only works for gases because it's based on the ideal gas law. But all we have to know in order to calculate the density of a gas is we have to know its molar mass, we have to know its pressure, and we have to know its temperature. So let's try to do this. Let's calculate the density of carbon dioxide at 25 degrees centigrade and a pressure of 1 atmosphere. So pause the video and try it for yourself, and then come back and see if you got the right answer. So to do this calculation, I'm first going to calculate the molar mass of carbon dioxide, and that is 44.01 grams per mole. Then I'm going to multiply it by the pressure, which is 1 atmosphere. And I'm going to divide by R 0.08206 liter atmospheres per mole Kelvin. And I'm going to divide by temperature, 298 Kelvin. Notice I converted the 25 to 298. And let's cross out the units that we can. So atmospheres will cancel with atmospheres, and moles will cancel with moles, and Kelvin will cancel with Kelvin. And the units we're left with are grams, a unit of mass, and liters, a unit of volume. So now I'm ready to put this into a calculator. 44.01 times 1 divided by 0.08206, and also divided by 298. And I get 1.80, and the units would be grams per liter. So that is the density of carbon dioxide under these conditions. And I'm going to do one more example. I'm going to go ahead and erase this. So here we go. Let me write the equation down for you again. So what was that? It was molar mass, see if you remember, times P over RT equals the density of a gas. So what I'd really like to know is the density of air under some circumstances. But air is not a simple gas, is it? It's a mixture of gases. We know that air is 78% nitrogen, and we can calculate that nitrogen has a molar mass of 28.02 grams per mole. We know that air is 21% oxygen, and we know the molar mass of oxygen is 32 grams per mole. And we know that air is 1% argon, and the molar mass of argon is 39.95 grams per mole. Now, I'm not including in this analysis of air, I'm not including the 0.04% of carbon dioxide that's in our atmosphere, and I'm not including any pollutants. But I can determine from this data an average molar mass for air. It's a weighted average. So we can calculate that by taking 0.78 times 28.02 plus 0.21 times 32 plus 0.01 times 39.95. Pause the video, do this calculation, see if we come up with the same answer. So I came up with 28.975, so I'll round that up to 28.98 grams per mole. And I can use this molar mass, because it's an average molar mass of air, to find out the density of air. So let me give myself a little space here. I'm just going to keep the result of this calculation, and I'm going to ask the question. So the question is, what is the density of air at a temperature of 98 degrees Fahrenheit? Oh no, we have to convert Fahrenheit all the way to Kelvin. What are we going to do? Well, we can just go to Google and ask, or we could just take 98 and subtract 32 from it. And then we just need to multiply that by 5 and divide it by 9, and we end up with 36.7 degrees Celsius. And then if we add 273, we end up with 310 Kelvin. All right, so the reason why I started in Fahrenheit is because most of you think of 98 degrees Fahrenheit as a very hot summer day. So let's calculate the density of air. For pressure, let's do this for a pressure that is slightly lower than 1 atmosphere. So we will give you that data as 756 torr. But now you're going to have to convert that to atmospheres. Remember how to do that? You just take the 756 and divide it by 760. So I end up with 0.995 atmospheres. Okay, so now I have every piece of data in the correct units, and I'm ready to find out the density of air under these conditions. So density equals molar mass, which is 28.98, times pressure, which is 0.995, divided by R, 0.08206, and also divide it by temperature, 310. So again, pause the video anytime you want and try to work ahead so that you can see if you're understanding. And I'm punching out on my calculator now. And here we go. So I end up with a density of 1.13. 1.13 what? Do you remember? Grams per liter. And that's how you calculate the density of a gas or a gas mixture. Basically, all you need to know is the temperature, the pressure, and the identity of the gas or the composition of the gas mixture. Okay.